Hello, everyone. Today is April 3rd, 2024. This is the Kubernetes Data Protection Working Group meeting. So today, yeah, we can get an update on the CBT project. I added this issue. I just want to briefly discuss this. There was a request for this one. And then we want to see if we want to, so last time we said we want Troy to present NetApp volume replication. I'm not sure if Troy is ready to present today or.
Yep, ready to go.
Oh, okay, cool. All right, then. Just quickly, so I think we know that the CSI spec is finally merged, and then so we can discuss when to cut a CSI spec release, maybe in the 6:30 meeting, Ben. Just to see if there is anything else we need to wait before doing that.
Did that meeting happen last week? Because I was on vacation last week.
Uh,
I may have missed the crucial meeting.
Right. So I think only Sada and me were there. Was a very, very short meeting. I'm thinking that we can also talk about that at a 6:30 meeting just to see if anyone is working on anything that we need to include.
Yeah, so it's the this change block tracking and what else is new that would be picked up by the release? Is that the only thing, or is there two things?
As far as I know, that's the only thing. I don't know if there's anything else because now this is I don't think we can make it in 1.30, right? So, but in 1.31, there may be other things. I don't know if we need to wait that long. So that's the thing. We want to talk about that in the.
Yeah, okay. Well, yeah, I guess that can be a SIG storage question. We don't need to cover it
Yeah.
here.
Yeah. So to say. I think this one we probably have not got much progress on this here, right? Process and car. I don't see one here. Do we get any more reviews on the cap with the same?
No, I don't see any additional feedback.
Okay.
Yeah, we'll follow up with folks.
Okay. And Ben, have you got a chance to take a look at that again after the CSS bank merge? Cap?
I can't remember honestly.
Okay, yeah, that's okay.
I think I took a look at it and I hadn't seen anything that changed, but I might have not gotten all the way to the bottom.
Okay, yeah, if you can take a look again. Yeah, I also pinned Michelle. Probably need to pin her again. Okay. All right. Yeah, thanks. And then I think I need to submit a request for this one. I think we talked about this one last time for new repo. So I will just, all right, yeah, I'll just put those names. All right, and then, so quickly for this one, this is someone submitted this one. I don't know if it makes sense to handle this in Snapshotter, controller and sidecar. So someone just submitted this one. So basically it's saying that if you use retain, it's kind of, it's kind of a pain, right? If you use retain, you always need to remember if you want to delete it. But if you delete, then the whole thing could be gone. Then you lost your data. So he was proposing to do something like, if you want to protect your PVC or your snapshot, somehow you just add this thing before delete snapshot. Oh, actually, this is add this on PVC. Actually, not sorry, it's not on snapshotter. So add this on PVC. So if you want to protect it, if this is there, if the snapshot controller sees this one, it will just automatically take a snapshot before this is getting deleted. Yeah, but I think I see the problem, right? Because depending on the storage system, not everyone allow the PVC to be deleted if you have snapshot anyway. So I guess this does not really work. This is only
Well,
for.
that's one problem, but I mean, there's a long list of problems I can see here.
Mhm.
This implies that like deleting a PVC object would cause the creation of a new object, and like what would the name of that object be, and under whose access credentials would that new object be created? I mean, it bypasses all kinds of normal things that are important in a cluster. My bottom line with something like this is I can see how you could implement it today without any changes whatsoever. Like, you know, you can just stick a finalizer on, or you can write a controller that puts a finalizer on every PVC, and in response to this PVCs getting deleted, it tries to create a snapshot. And unless like that approach literally won't work, then I don't see any reason for us to create some built-in feature if it's easy to put this on a higher layer, right?
Yeah, that's
So-
what I thought.
I guess the only question is, do the existing controllers let you create a snapshot of a PVC that is in a deleting state? Like, or
No,
would
we actually have some checks, I think.
we have it checked?
So,
Okay,
yeah,
so
basically
that
then
would
adding a lot of more things. Yeah, you need to change
that would be the crucial problem is
Mhm.
if you try to do this with a finalizer, the finalizer wouldn't trigger until after the PVC was in a deleting state. And at that point, you might not be able to follow the normal snapshot process, in which case maybe we should fix that problem and say, okay, we're going to create a mechanism for allowing the snapshotters to take a snapshot of a volume that is in the process of being deleted, but hasn't been deleted yet. Maybe. Does that make sense?
Mhm. Yeah.
But yeah, I don't like the
feel
idea of
it's-
automatically creating new
I know
objects.
it's weird, right? It's weird. It definitely looks okay. Yeah. Okay. Yeah, so I also heard some people actually always just use the reclaim policy because they're so retain because they're so afraid that their PVC get deleted by accident. So yeah, but definitely this can also be a problem. Then you could get resources leaked, right? You're not paying attention, then you don't even know the handles. You can delete them afterwards. So yeah. No, yeah, I think probably better for this to be done at higher level and
But I do think it would be interesting to think about if we're going to inhibit creation of new snapshots once the PVC goes into a deleting state, then when would you naturally trigger this behavior so that you could get the desired effect? Because that is a problem. If
Okay.
volume snapshots are going to fail after the PVC starts deleting.
yeah. So yeah. And then for that one, we might need to add something like what he's suggesting here, some special annotation or something. If you do that,
Do you know where the check is performed that will notice that the PVC is being deleted and say, no, I'm not going to create the snapshot? Is that in the volume snapshot controller?
I need to check. I think it's snapshot controller somewhere. It's probably checking the timestamps. I need to take a look. I don't remember exactly.
Because maybe we add a command line flag to that controller that says allow snapshots of deleting volumes, and that's all you need.
Mhm.
Then someone who wants to create this behavior can just write a new controller that puts finalizers on all the PVCs, sets that flag, and relies on the fact that the finalizer will trigger
Mhm.
to go do this thing.
Okay. Yeah, so that might still require some code changes, right? So okay, let's take a look. All right. Okay, so all right, so now let's move on to this presentation. Shui, if you're ready, I will make you the co-host. Let's see. I will stop sharing. Do you have any slides that you want to share?
Yep, I have a presentation. I'll start sharing.
Great. Yeah, if you can provide that. You can do that after the meeting so people can look at this one later.
Okay, sure. Yeah, I can share it.
Right.
So yeah, quick introduction. I'm Trey Thomas. I'm a software architect at NetApp. I work on primarily Astra, so I'm sort of a consumer of this feature of Trident. But yeah, here today to talk about how Trident has implemented volume replication with NetApp's SnapMirror feature. So just quick agenda. I'll go quickly over SnapMirror in general and ONTAP and how it works and how it's different from different types of replication and other storage systems. And then go through how we can configure this with Trident CRs, and then look at replicating individual volume snapshots, and then how failover works. So yeah, so for the intro to SnapMirror, basically, it's a capability to replicate volume data. The destination volume can be in the same ONTAP cluster or in a different ONTAP cluster that has been peered. There's also another layer of vServer peering that happens, but that's not too critical here. You can use this for data protection or migration. And there's two main categories of replication policies. There's asynchronous and synchronous. And I did want to call it that our asynchronous replication is based on snapshots. So basically the way it works is it replicates the snapshots from a source volume to a destination volume. And then your RPO is based on the frequency of new snapshot creation and replication. This differs from asynchronous replication and some other storage systems where the data starts replicating immediately after it's written. With ONTAP's SnapMirror approach, there is no replication happening until after you've created a snapshot and then started replication of that snapshot. Doing it this way enables app consistency. If you quiesce your app while the snapshots are captured, so that's different from just replicating data as it's written and letting it lag behind a little bit. That's typically how asynchronous replication works in some systems. And then we also have synchronous, where there's strict versus, or there's synchronous versus strict synchronous to configure whether writes are blocked if and when replication fails, and it's just crash consistent. So there's no snapshots here necessarily. So it isn't always app consistent. Mostly today I'm going to talk about the asynchronous, but synchronous is kind of a simpler to set up even than async. So I guess any questions about SnapMirror before I get into the Trident implementation? All right, I'll move on. So getting into the Kubernetes resources. So you can start with a source PVC. It doesn't need to necessarily be pre-provisioned with any replication capabilities, as long as it's on a system that supports replication. But say you have a PVC here named Postgres data, you can come in and create a Trident mirror relationship CR on the source volume. So it's referencing the source volume. And what this gives you is in the status of the Trident mirror relationship CR, you get a local volume handle that gives you a handle you can use to come over on the destination side, which can be different namespace or different cluster. You can come in and create a destination PVC with an annotation pointing to a TMR, Trident mirror relationship. And then in that Trident mirror relationship, you specify the handle that you got from your source Trident mirror relationship. So that's your remote volume handle on this side. So this annotation tells Trident to basically block and not actually provision this PVC until it finds a TMR with this name. And then once that is present, it has the information it needs to provision this volume in the correct storage backend and in the correct with the correct configuration to act as a destination for this replication. So once that is created, this Trident mirror relationship will begin replicating the volume data and then it has a status that will indicate when it has finished establishing. There are different policies you can specify in here. I didn't really go into detail around that, but you can do asynchronous versus synchronous, and you can do also a schedule. You can specify a schedule which just gets passed down to the underlying storage system to tell it when to trigger new snapshots and replicate those. Or you can explicitly replicate new snapshots instead of relying on the schedule. The issue with letting the storage system handle the schedules is you kind of lose your opportunity to do the quiesce of the app for app consistency, because the storage system is just taking snapshots based on its schedule and not triggering that. So in Astra, we always do this explicitly rather than relying on the storage system schedule.
Hey, I have a question. How?
Sure.
Okay, so if it's in different cluster, how did this get triggered? I guess I did not follow that part. So how did the second cluster knows it needs to? I guess I missed the part, like how those resources are created. It's created by the controller on the source. Is that?
Yep. So if it's a different cluster, I mean, it's all just based on whether it's the same cluster or a different cluster. This destination Trident mirror relationship really just tells Trident to provision this volume as a destination, and then this handle is sort of an opaque handle that gives it a pointer to the underlying volume in the source cluster, the source ONTAP cluster. And if it's peered, if this can access an ONTAP cluster that is peered with the source ONTAP cluster, then it just works out how to make this association based on that handle.
I mean, how? Okay, who creates this CR? The one on the one on the right hand side. This is TMR2. Who creates this CR?
So that could be the user coming in to create this and set up the replication.
Oh, so it's not okay. So that was my question. I was wondering if automatically triggered by the left hand side, this TMR1, or you're saying it's actually user to go create.
Well, it can be the user or any higher level application, right?
Yep. Yeah. Different. Yeah. Exactly. So with Astra, we're doing things at the app layer.
So Astra will. So I guess in case of Astra, does Astra create this, because Astra probably has knowledge of both, right? It knows how to connect to both.
Yep. It has visibility to both. And really, so this source one, this is a little bit confusing in the design. This source one doesn't actually need to be there. The only purpose it's serving is to expose this handle in the right format that you can sort of copy and easily paste into the remote volume handle here. So yeah, with if you have knowledge of the structure of this handle, you can just create this destination TMR without creating a source one. But this just gives you an easy way to get access to the source handle.
I believe the reason that there's a TMR on both sides was because I was part of the design for this years ago. It was because when you want to break the relationship and reverse it, then you'll need the TMR on the other side, and just having it already existing is convenient.
True. Yep, that's a good point. Thanks for adding that. Yeah, definitely. Yeah, so that's a capability I'll get into in a little bit. You can reverse this and replicate in the other direction as well. So yeah,
so it's the same. Okay, so the handle is actually the same. It's just so you don't need to know the volume handle that is created on the remote side. I was just normally you have two volumes, right? On one on the local, one on the other side. So in this case, the same handle, meaning, okay, I guess I'm a little confused. Normally you would have a pair, right? Are you saying you don't have a volume created on the remote storage system? I guess I'm missing that part.
Yeah, so this PVC would still correspond to a PV and a different volume in the storage system.
So I guess all right, so yeah, each PVC, of course, the corresponding PV will have that. So is that volume handle not the same as this volume handle?
Yeah, this volume would have a different local volume handle. So there's local volume handle and remote volume handle
What
in
is,
these two.
yeah, I guess I'm a little confused. What is this? What is this local volume? What does this local volume handle mean? Is
So
it
that
really a volume is there really volume on the storage system or is this not? This is something different. But I guess I'm really confused with what is local.
yes, so this local volume handle is basically an opaque way to reference the source volume here. So the volume that you're replicating from in the underlying storage system, and you use that and you specify it on the destination side as the remote volume handle that it should replicate from. And then this volume, this trident mirror relationship would also get a local volume handle as part of its status. I just didn't include that here, but that local volume handle would refer to the destination volume.
Are you saying this local volume handle can be anything? It just has to be unique or something? It's not really like some resource. And then
Trident fills in the field with the right value.
Yeah, so it's in the status of this one, so that the user doesn't specify it on this side. Yeah, Trident provides the handle
is this the
that can be
handle
used.
for the, okay, yeah, I guess that was, or is this the identity for the pair itself?
No, it's for the source volume. So basically, it's I should have included an example of it here, but it's
Yeah,
basically
I was just,
an ID
because
of
I
the
was just
source
wondering,
volume.
well, I will have another identity. It's okay.
It's an identity that makes sense outside the cluster, so that a different ONTAP system that has a peer relationship with the original system can find the volume
Mhm.
given no other information.
Okay,
Exactly. Yep.
okay.
Yeah. Any other questions on this slide? Hopefully we cleared it up. It's a little confusing with all the handles and everything, but yeah. So moving on to replicating new snapshots. So I mentioned you can set a schedule and the replication just happens kind of behind the scenes. But some users and for example in Astra, we care about explicitly creating volume snapshots and then replicating those volume snapshots because we want that app consistency. So here, I just kind of grayed out the PVC and the source TMR. We have a volume snapshot that the user creates or a different application creates that is just a normal volume snapshot of the PVC, and that gives us a volume snapshot content outside the namespace, and that has a snapshot handle. So similar logic here. We can come over to the destination side and create, this is a relatively new CR that we added, Trident Action Mirror Update, where we point to the Trident Mirror relationship, and then we provide that snapshot handle. And this is sort of an action that we're triggering that goes and explicitly replicates this volume snapshot within the storage system using the existing relationship over to the destination. So create this, and it has a status that indicates its progress through triggering that replication and seeing that it succeeded or failed, and you can observe that in the status of this update CR.
Where do you add the scheduling? That's not through any of the CRs?
Correct. So there is scheduling you can configure on the destination Trident mirror relationship, but that would be just telling the underlying storage system to do scheduling. But that will effectively get you crash consistent snapshots if you don't do any sort of quiescing around when you create the snapshots. So like in Astra, we don't use that schedule capability within the TMR. We have separate scheduling in the Astra controllers that create the volume snapshots and do the quiescing logic there.
Okay.
So yeah, any other questions on this update CR to trigger a replication of a snapshot? All right. The other thing I didn't mention here is we do also have a capability in Trident to create a volume snapshot on the destination side that references the snapshot that we just replicated to this destination volume. So it's sort of an import of the volume snapshot. But yeah, that's sort of optional. So I'll kind of the last step in this is failover. So if you have say you have a failure on your primary side of the relationship, you can come into your destination Trident mirror relationship and change its spec.state to promoted. And what that will do is by default, it will use the latest snapshot that it replicated, and it will turn this PVC into a normal read-write volume that that comes up and is usable based on that most recent snapshot state. We also have the option to provide a promoted snapshot handle where if we want to explicitly use a snapshot that's not necessarily the latest, we can give a specific snapshot handle here, and it will use that one instead of the latest when it promotes the volume. So, and promoted here, I should elaborate a little bit. ONTAP has the concept of a data protection mode volume. So the volume, while it's being replicated to, can't be used like a normal PVC. Like it will fail to mount to a pod, and or at least it won't be writable. And to make it a normal usable volume for the app, it has to be promoted, and then it becomes a normal read-write volume. So yeah, any questions on this promote or failover step?
So who is updating this to promote it? This would be, is it Trident or is this Astro who is changing this?
So Trident won't automatically do it. It would be either the user doing it manually, or it would be Astro doing it based on a higher level operation that is controlling these. Like for example, in Astro, we do this for the entire app. Like we'll go promote all the volumes of a given app at the same time. But it could be the user directly as well. Yeah, Trident doesn't have any sort of like auto detection of like if the source side is having an issue and it needs to promote. It doesn't do anything like that. It just waits for the spec state to be updated externally to this promoted value.
Mm-hmm.
Yeah, it would be triggered by like either detection of a hardware failure or a site failure or just the desire to mirror or to migrate something, right?
Yep.
You could say, oh, I'm migrating, so I'm going to go ahead and promote the secondary.
Okay.
All right, and that's my last slide. So Ben did mention we had the ability to establish this relationship in the opposite direction as well. I didn't get into that until maybe a little more of an advanced use case, or at least a little more difficult to explain. But basically, it works the same way as when you initially set it up. You would just come in and you'd have your destination in the promoted state instead of the established state. And then what you do from there, if you want to replicate in the opposite direction, you would come to your source side and create this TMR if it doesn't already exist, or if it's already there, you would update its remote volume handle to point to the local volume handle of the what was previously the destination volume, and then you would change the state of the TMR from promoted to reestablished is what we use there. And
so you basically don't change the like on the conditions. Left-hand side is called local, the right-hand side called remote. You don't change that; it still stays the stays
Yeah, so
like that.
the local and remote here. So local is referring to, this PVC that's on this side, and here the remote is referring to, the other volume that we're replicating from.
I mean, even even when you, let's say you fail over, you would, okay, I was just trying to, even when you fail over, you still call the left-hand side local. Oh, did I miss something? Okay, see local. Even after you fail over, the left-hand side is still called the local, and the right-hand side is still called the remote.
No, but
So
both sides have a local and a remote, and they're reversed,
Oh, you
right?
have both?
Yep,
Do you?
yep, exactly. Yeah. Yeah, so
Oh,
the spec will have the remote volume handle.
all right. Okay. So this one, okay, it's not showing, so I was trying
Yeah, and sorry, I should have included the status here, but yeah, the status of this one will also have local volume handle, and that'd be pointing to this,
okay.
the PVC that's local to this TMR.
Okay.
Yep. So yeah, that reversal is a little tricky. I could have included a slide for that. I can definitely add one if that would be interesting for anyone, but didn't want to make it too confusing just for this initial presentation at least.
And so using that promote of a specific snapshot, you can achieve a planned failover that's lossless, right? By shutting down the app, taking a final snapshot, transferring that snapshot to the secondary, promoting that specific snapshot, they're bringing up the app on the second side. You lose no data, right?
Yep. Yeah, that's really all dependent on what you do on the source side before you create the snapshot. If you shut down the app, scale all your pods to 0, and then do your volume snapshot, and then you either ensure that those snapshots finish replicating before you change the state to promoted, or you explicitly specify that snapshot's handle and the promoted snapshot handle. You can get you can be confident that you're promoting the correct snapshot. The other use case for this promoted snapshot handle is if, for example, you have a whole app that you're replicating, and say a replication of a set of snapshots was in progress when a failure happened. You don't want some, and you need to fail over your app. You wouldn't want some of your volumes to be promoted using a newer snapshot than other volumes. So this enables you to say, use this explicit snapshot even though it's not the latest. If for example a snapshot finished on certain volumes and didn't finish replicating on other volumes.
Very cool. Thanks, Trey.
Sure. Yeah. Thanks for adding the color on the initial design for this, because I wasn't around for that part. So that's good to know.
Any other questions? Anybody? Xing, did you have other topics?
No. So, and this is actually on your GitHub, right? So if you can write a link to those, would be great.
Yep. I can add the link to the Trident GitHub, and I'll get my presentation published somewhere that's available and send a link to that as well.
Okay. Okay. Great. Yeah. Great presentation. I see that this is looks very different from Tom's design, so we have to look at this one to see if you want to come up with a common design, how that would look like.
Yeah, that's gonna be the challenge. I think it's probably very different.
Yeah,
Between our
definitely.
two implementations. I'm not sure if there are others that we can take a look at as well.
Yeah, I know that I know Red Hat, or I think maybe that now they are IBM. They have something they presented some time ago. We can also look at that one. So yeah, everyone come up with their own design and they all look very different. So
Well, I think the differences come down to underlying storage systems expose different primitives, right? And so that's the challenge with trying to create like the one API to orchestrate all of these, is that it's
yeah,
very hard to have an API that, given all these different storage systems with their different mechanisms, they can actually implement the same thing.
Yeah, I was kind of thinking the same thing. Our asynchronous replication is not based really on explicit snaps. It may be implemented internally in the array as kind of a continual stream of snaps. But
Well, yeah, that's how the NetApp one works. Is if it needs to take a snapshot, it'll take a silent snapshot on the background and just use it for the transfer. But any snapshots the user has taken explicitly will come along for the ride to the secondary.
yeah, but the presentation that Trey shows looks like it's always will make it visible to the user, right? It always goes through
Well,
the.
if you're using explicitly created snapshots, then yeah, but the
Oh, but you're
scheduled
saying
version,
there's also a way
the scheduled
for.
version,
Okay.
yeah, then the storage device will just create hidden snapshots that Kubernetes doesn't see in the background and use those for the transfers. And the downside is it's only crash consistent, as Trey was saying. So
right.
so that it's better to have application consistent snapshots, but yeah, like if you don't need them, you can just transfer whatever's there by taking a silent snapshot and transferring that.
Okay. Yeah, I have to look at this and think about it.
So Xing, are you actually like working on a comprehensive proposal that like we could have a common replication API? Like, have you started
I have
sketching
not.
that out?
I have not started. I was just looking at this. I
Okay.
just want to look at this first and then see what we can. But I'm definitely interested in have some common thing. I just trying to trying to reconcile at least the what Tom has,
Yeah.
what Trey has, at least for the async one, and see if we can have something. And I also want to go back to the one that presented previously, right? You were also there. I think both of you were. I think
Yeah,
Tom.
I'm
you were
forgetting
there.
the gentleman's name who presented.
Yeah,
from-
Sham. Yeah, I don't know if he's still around. But I think his presentation is somewhere in the agenda doc. You also need to take a look at that one and see how
Yeah.
that's different. Yeah.
My recollection is it was like 80% similar to the NetApp design with some crucial differences.
Oh, right. So he has some. Okay, so there's one thing that Trey you do not have is you don't have like CSI spec extensions, right? Which I think Tom you have, and the Red Hat one also has those, right? You don't need CSI spec extension for this proposal, isn't it?
Yeah,
But
and Trident, it's annotations for a couple aspects of it, and then CRs.
Yeah, so
So
that's actually a major difference. Yeah.
well, but crucially, like the reason Trident can get away with that is because they have Kubernetes specific integration. Like without that Kubernetes specific integration, you can't leverage this feature
Right.
because it relies on Trident being able to, when the create volume call comes in, it reaches back around to Kubernetes and says, hey, does that PVC have any annotations? If so, I'm going to behave differently
Right.
than I would
Basically,
normally behave.
Basically, you're saying it's like the driver has knowledge of Kubernetes. It actually checks the CI,
Yes.
right? Yeah.
Yeah.
Which Tom, you're saying your
The
that's
CSI extensions are really only necessary if you don't want the driver to be able to go read and manipulate Kubernetes objects.
yeah.
We chose to put that in a sidecar. We could get rid of the extensions by essentially combining that sidecar and putting it in the driver and letting the driver read
Yeah.
CRDs, for example. So I don't think that's a major differentiator. I mean, you
Yeah.
could you could make a spec that could do either one. I wouldn't specify the CSI extensions, I don't think. If you were trying for a general solution.
Yeah, but I think I think the best practice is actually for the CSI driver not to communicate with Kubernetes directly. But I know we also do that.
Well, given the lack of proper support for replication in CSI, like this is the only way,
Right. Yeah.
But we could propose a CSI change where, you know, there was a new type of crate volume, crate replicated volume, where the appropriate cookie, which is that volume handle, would get passed through the CSI layer. The challenge then is just all of the weird state transitions, right? Because volumes can start out as not replicated and become replicated, and then they can become not replicated, and the direction of the replication can be flipped, and modeling all that CSI would get nasty.
Yeah, definitely. Yeah. Okay. Yeah. So we need to think about this one. Yeah, it's probably still I think it's still better to have those in the CSS spec itself, because otherwise I think I don't think we can have some common proposal and ask drivers to communicate with Kubernetes directly. Yeah, which is typically not.
No, I think if we were going to have a CSI layer solution to this problem, you would need to solve all of the problems at the CSI layer and abstract away Kubernetes. And that's a very tall order given the number of use cases that these systems tend to rely on.
Definitely, yeah. Okay, so I think we need to look at this and think more and see.
A question for Trey. Internally, actually, some of our arrays are snapshot based, and they ship the differences between the snapshots. Is that what you mean when you talk about your snapshot scheduling?
Not exactly. So the ONTAP level snapshot schedule basically will just create you know, a normal user visible snapshot and replicate that whenever the schedule kicks in. So it's not like some kind of internal representation. It's actually,
but it's invisible to Kubernetes.
Right. Yeah, it doesn't get created as a volume snapshot in Kubernetes. Yeah, it's just at the ONTAP layer.
Right. So is ours. That's what I was asking.
NetApp's async replication is based on snapshots. NetApp also has a synchronous replication, which doesn't require snapshots. Just every single write just goes to both places.
Right. Yeah, we have one of those too.
Yeah, and it sounded like the way the Dell replication works for async was, you know, as soon as a write comes in on the source side, you know, it gets acknowledged to the user, but then it immediately gets replicated right then. So you sort of have a constant stream of updates coming into the destination volume. And that's how some of NetApp's other products work outside of ONTAP, you know, SolidFire and E-Series replication that do async in a similar way. But in ONTAP, it's always, you know, their async is just always, there has to be a snapshot on the source side, an explicit like user visible snapshot. And then that's what shows up on the destination side.
Yeah, we don't have user visible snaps as part of the replication unless the user requests them. But internally, that's pretty much what the array is doing automatically. The time frame is set by the RPO and can vary across, you know, the arrays and what they can support.
Is that a time frame as to how much lag is allowed, like replication lag, or what is that?
Well, I mean, the recovery point objective on some of our systems can be, for async, can be as low as 10 seconds.
Wow, so it takes a snapshot every 10 seconds in those situations?
Yeah. Mhm.
Nice.
It's only transferring the deltas, of course.
Yeah, you must have a very lightweight snapshot implementation to be able to churn them that fast.
Yeah, the details of that I know not.
Yeah, Trey, I'm actually curious. You mentioned some async replication technologies that don't rely on snapshots. How do those ones cope with loss of connectivity?
So yeah, like our solid fire and snap and E-series systems, as I understand it, will effectively just as those changes flow in, they just keep track of what delta has been already synchronized, and they're just synchronizing the deltas. So you can sort of call that a snapshot internally.
But like if the network link between the primary and the secondary were to go down for 10 minutes and then come back up, it would remember like, okay, I've got to now sync the last 10 minutes of changes and I know where to find those.
Right.
Like,
Yeah, I think in those systems, the source side is keeping track of what has been replicated successfully.
Yeah,
Okay,
so our async replication sounds more like what you just described.
Yeah, I think that's probably more common, at least with my experience with different storage systems. But yeah, ONTAP is explicitly snapshot. Yeah.
Yeah, the problem is that window of unreplicated changes can grow without bounds, right? The user keeps writing and writing and writing, and you keep being not connected, then you could have a massive amount of changes to transmit. At some point, you have to give up and say, I can't buffer all this.
Yeah.
Yep, and that's something you have to sort of track and monitor as replication lag and also storage consumption that you're continuing to use to track that delta. Yeah.
All right, Xing, you have anything else? I think we might be ready to wrap up.
No, I don't have anything else. So yeah,
Right.
Trey, if you can send me your slides, or if you can just provide the link in the agenda doc, either way it work.
Xing, if you could point back to the Red Hat presentation, I don't remember it.
Okay, yeah, I will
was
find that
probably years ago or something, but I might go back
it was about
and
2 years
listen to the
ago.
recording.
Yeah, I will find that and I'll put that in, somewhere in today's agenda doc later on. Yeah, I will do that so we
Okay.
can review that.
Thanks.
All right, thank you very much, Trey, for your presentation.
Sure.
Yep.
Thanks,
Yeah,
Bill.
thank you.
Thank you.
We will discuss this again. All right, thanks everyone.
Thanks.
Bye.
Bye.